Okay, here are a few examples on verifying trig identities. It can be pretty difficult to teach how to verify trig identities and how to learn it, because there's not just one specific, only one way to learn how to do this. There's a lot of different paths that you can take, and all of it has to do with adding, subtracting, multiplying, and dividing, expressions and fractions, and using identities to trade things that we know. So one strategy that can be applied here is that we can take everything that's not sine and cosine and trade it according to what we know. So I'm going to start with changing the cosecant to be 1 over sine. And then over on this other side, I'm going to trade this cosine is already cosine, so we can leave that. We're going to trade the cotangent to be cosine over sine. Okay, so that's strategy 1. Trade, express everything in terms of sine and cosine. Okay. Next, we need to make each side a single fraction. Over on the left side, we've got a subtraction happening. So to make subtraction work, we are going to need to multiply by a common denominator. So sine over sine. And that would make our outcome, we've got 1 over sine of x minus sine squared over x over sine. So that all turns out, after we combine it over the common denominator, as 1 minus sine squared of x over sine of x. Okay, now here on the other side, I'd also like to combine that one. So this is a multiplication problem. So I'm going to put a 1 under that so I can think about that. Multiply the numerators. Oops, cosine squared of x, and then multiply the denominators, sine squared of x. Okay, so that means this side equals cosine squared of x over sine of x. Alright, so our denominators are the same. So this is true. We can verify this if the numerators are the same. Well, if we take a look at our Pythagorean identity, it says that sine squared of x plus cosine squared of x is equal to 1, and rearrange that a little. If I subtract sine squared from both sides, I can say that cosine squared of x is equal to 1 minus sine squared of x. So by that identity, this can get traded out for cosine of x, and then we've got cosine squared of x is equal to cosine squared of x, and it is verified. Okay, here's another example. That we didn't quite get to in class. In this example, we are trying to transform the left side into the right side. So our goal is for everything on the left to turn into tan squared x. Okay, so again, it is really hard to teach how to do this because you just have to try some things. So the first thing that I would want to do, I think I'm not super familiar with working with secant, so I would like to change that to 1 over cosine squared. And then I could, because now I've got cosine and cosine, I could distribute this, but I know that if I've got both cosine and sine in a problem, it's getting closer to making a tangent happen, because I know tangent is made of cosine and sine. So I'm going to use a Pythagorean identity to trade out 1 minus the cosine squared, because from the Pythagorean identity I know that 1 minus cosine squared is equal to sine squared. So I'm going to trade that with sine squared of x. And if I multiply those together, I've got sine squared over cosine squared. And I know that sine squared of x over cosine squared of x, according to the identity, is the same as tangent squared of x. So they match. All right, here's another. Okay, so same strategy. We're going to try to work on the left-hand side so that we can change it into the right-hand side. We're going to try to change it into sine squared of a. So let's see, cosine squared of a, I like that. That's nice the way it is. I've got a secant and a cosine. So let's start by changing the secant to 1 over cosine. Now I'm going to try the distributive property. Multiply these together. So cosine of a times 1 over makes 1. Cosine of a multiplied by the cosine of a makes cosine squared of a. And according to the Pythagorean identity, I know that cosine squared of a is equal to sine squared of a. Therefore, they match. All right, another example. We can also verify identities by working on both sides independently. But we can't cross over that equal sign. We need to work on each side by itself. So, and then if we can get the two sides to match in the end, then we've verified the identity. So we're verifying by working on each side independently. So I'm going to start by changing everything into sine and cosine. So my tangent ends up with sine over cosine. Cotangent is defined as cosine over sine. There's my equal sign. I'm going to change cosecant to 1 over sine. And my secant to 1 over cosine. Okay, so now I'd like to create a common denominator. I'd like to put together these two to make a single fraction. So that's fraction addition. And put these together to make a single fraction multiplication. So when I multiply this side, I get 1 over sine x cosine x. They just multiply right next to each other. In this case here, I'm multiplying by my denominator is going to be cosine times sine. Oops, I forgot my x right there. So cosine x sine x, which is equivalent to this other one, so we're doing pretty well. Okay, so I need to have a common denominator, multiply this by sine x over sine x to make that common denominator, and over here multiply by cosine x over cosine x. So I get right here sine squared x plus cosine squared x. Okay. I'm going to claim done because I know that sine squared x plus cosine squared x can be replaced with a 1. So I've got 1 over, and just to make them look exactly identical, I'm going to switch the order here. Done. Okay, one last example. Alright, so I've got these two, and again I can independently work on each side of this. So I'm going to start by switching out everything in terms of sine and cosine. So my cosecant of x can be replaced with 1 over sine x. My cotangent can be replaced with cosine over sine. Over here I've got 1 over, now this is going to be little fractions within a fraction, so 1 over sine, and minus 1 over, oops, cotangent would be cosine over sine. Okay, fortunately I have common denominators already, so I'm going to add these two fractions together. My denominator is already sine, so I add my numerators, 1 plus cosine of x over sine. And here I've got 1 over, I have a common denominator already, so 1 minus cosine of x over sine. So I've got 1 divided by a fraction. So with our fraction division in mind, we keep the numerator of 1 and multiply by the denominator, the reciprocal of the denominator. And the reciprocal of that denominator is sine over 1 minus cosine of x. So, it is still my goal to make one side turn into matching the other. So, I would like to try something. I'd like to get these denominators on each side of my equal sign to be the same as each other. So I'm going to multiply the right side by the conjugate. And a conjugate is where we multiply by, says 1 minus cosine of x. I'm going to multiply by 1 plus the cosine of x over 1 plus the cosine of x. This is multiplying by a giant 1, so I haven't changed anything. When I do this multiplication, since this is it's going to be a difference of squares, the result here. So on this side, I end up with 1 minus cosine squared of x multiplied by sine of x, or in the numerator, sine of x times 1 plus cosine of x. Now, I know that this is equivalent by the Pythagorean identity to sine squared. So I'm going to be able to simplify one of my sine x's divides with the sine x in the numerator divides with one of the sine x's in the denominator, leaving just sine of x in the denominator. And now they are equivalent. This side on the left is equivalent to what we have left on the right. And they match. Now, using the idea of the conjugate, I thought of another more efficient way to solve this problem. So multiplying by the conjugate on both sides, the numerator, we get cosecant x plus cotangent x all over the difference of squares. Okay, since this, according to one of the identities, is equivalent to 1 minus or 1 plus cotangent squared, the cotangent squareds cancel, and we get cosecant x plus cotangent x over 1, and they are equivalent. So there's another way. Okay, hope this helps. See you in class.